Okay, then look at this question. It's a very interesting question. Now, given that this velocity 4t square minus 8t plus 3. Now, velocity equal to 4t square minus 8t plus 3. Okay. Now, if you want to find the acceleration, what will you do to this velocity function? You differentiate dv dt. This will give you actually the acceleration function. Okay. Now, so what you do is, if you differentiate dv dt, you have 8t minus 8. This is actually the acceleration. So when t equal to 3, dv dt, or the acceleration become 8 times 3 minus 8, that will give you 16 meter per second square. Now, okay, now we're going to look at the part 2 here. Find the value of t for which the particles is momentarily at rest. Mean v equal to 4t square minus 8t plus 3. So when v equal to 0, 4t square minus 8t plus 3. If you factorize, or 12, 6 times 2, okay, so is 3 times 2, so is 2t again, then is 3 here, minus 3. There is a mistake here, a lot of this part here. Okay, now this becomes 2t minus 3 and 2t minus 1. Okay, so when v equal to 0, t is equal to half and t equal to 3 over 2. Okay, now let's sketch the graph first. In other words, when t equal to half, this is t, this is velocity, this is half, 0.5, half, or t equal to 1.5. This is when v equal to 0. If you sketch this, since the minimum curve, so we will get this. Okay, the shape is not so proper. Okay, now then this is 3 here, because the y-intercept is 3. Okay, now what is the significance of this graph? Now from 0 to 0.5, you can see that the speed is positive. No doubt become less, but it's positive. That means it's same direction, because it's positive all the way. Okay, the moment when it exceeds t equal to 0.5, your velocity become negative. That means the particles actually is moving in the opposite direction after t equal to 0.5. Okay, then after that the particle continue in that opposite direction, negative direction in the sense. So by the time we reach t equal to 1.5, okay, we change its direction again, become positive. Okay, now let's look at the number line, the distance line. What it's saying is let's say this is t, this s equal to 0, this s, okay. What it's saying is, let's say I put t here, t is equal to 0.5. Okay, now that means the particles was moving in this direction, in a positive direction, from here all the way until t equal to 0.5. Okay, in this direction the velocity is positive, as we have explained earlier. Now, then after t more than 0.5, the speed become negative, v become negative. That means to say, at this point onwards, okay, the particles is moving backwards. Okay, the direction is negative. Now, and at the point of 1.5, at the distance of 1.5, sorry, at the time of 1.5 second, you change direction again. That means from here onwards, it actually move backwards again, forward, become positive. Okay, I mean at this point here, t equal to 1.5. Okay, now at which position is this point when t equal to 1.5? To find this, we have to integrate. Okay, we have to integrate this in order to find the distance. Okay, so we will go ahead and integrate this. This value of t will be t equal to half. This is the answer. Okay, now let's integrate this. V equal to 4t square 8t plus 3. D is actually ds dt equal to 4t square minus 8t plus 3. Now let's integrate dt. Okay, so cancel this, s. Now this become, if you integrate this whole thing, you will end up 403 t3 plus 4t square plus 3t plus c. Okay, now if you read the question carefully, he said that t second after leaving a fixed point. Okay, I mean at this t second, this is the speed. Therefore, when it at the fixed point, or the 0 point, t is equal to 0. So we can say that s is equal to 0 when t is 0. So if all this 0, 0 plus 0 plus c, therefore c is equal to 0. So you have this s equal to 4/3 t3 minus 4t squared plus 3t. Now I want to check when t equal to 1.5, where is the position where you make this turn again. Okay, so substitute t equal to 1.5, s equal to 4/3 times 1.5, 3 minus 4 dot 1.5 square plus 3 times 1.5 times 1.5.